As we've learned, the concept of cognition is defined as all the mental activities associated with thinking, knowing, remembering, and communicating. Basically, these are the activities that we try to capture with various imaging techniques. But how exactly do we get from sensations and perceptions to cognition? How do we think? Humans form concepts or mental groupings of similar objects, events, etc. to help in our cognition. Our concepts are often divided into categories or smaller groupings of similar things, living versus dead, plant versus animal, etc. Take, for instance, the concept of paper. And then think of all the different kinds of paper we know about and organize in our own heads. There's writing paper, and that includes different kinds, and graph paper, which also has different kinds, and wrapping paper, and also butcher paper and parchment paper and wax paper. We categorize our concept of paper in lots of different ways. In our minds, we tend to place objects into categories either by their definition, this is wrapping paper, or by prototype, a mental image or best example that incorporates all the features we associate with a category. For instance, when most of us think of writing paper, we think of the kind that is hole punched so it fits into a binder. That's our prototype of writing paper. Because humans use these common methods of mental organization, we can predict how someone else might think. Let me prove it to you. Even though I, as your teacher, have known you all for varying amounts of time, some since 10th grade, some just these first few months of school, I already know quite a lot about how and what you think. I'm going to read aloud, and you'll see on screen, a series of words. In the pause between each word, I want you to quickly jot down the first example that comes to your mind with each word I announce. Bird. Color. Triangle. You can draw this one if you'd like. Hero. And here's the last one, philosopher. Now, here are my predictions for what most of you jotted down. For bird, I predict most of you wrote eagle. Maybe some of you wrote down a smaller bird like robin or sparrow. Or, since we're in Texas, maybe some of you noted grackle. For color, I'll bet most of you wrote down red or blue. Or, if not, it was some primary color. For triangle, I'll bet most of you drew an equilateral triangle. For hero, I predict most of you chose a superhero, or a first responder or soldier. For philosopher, I predict most of you chose one of the Greeks, Socrates, Plato, or Aristotle. Now, I know I was pretty accurate with my predictions. And why? Well, as previously mentioned, humans tend to think in terms of the best example of a category, and within a given culture, there tends to be considerable agreement, even near consensus, regarding these prototypes. For example, if I'd done the same exercise with a group of Mexican students, then I would have predicted that their choice of colors were likely red and green instead of red and blue. Let's try a similar exercise. I want you to think of a cat. Think of how you'd describe one to someone who's never seen one before. Jot down a description of your prototype for the cat concept. Now, here's an image of a domestic feline. I'm going to bet that most of you will agree that this is a cat. In fact, most of you probably thought of something along the lines of this image when you described your prototype of a cat concept. Now, what about this image? Is this a cat? Well, it is, right? But which is the cattier cat? I'll bet, after some consideration, that most of you will say that the domestic feline is the best prototype of a cat. And that's because we humans usually identify the big cats like tigers and lions more specifically by definition. And this example should help you realize that we humans have prototypes for just about everything. Let's take ethnicity, and let's use mine as an example. I usually check the Hispanic Latino box whenever I'm asked my ethnicity. But in reality, I identify as Chicana or Mexican American, which, by definition, is an American of full or partial Mexican ancestry. In the United States, in Texas, and in our town of Austin specifically, there are many people who would define themselves in a similar way. But what is our American cultural prototype of a Mexican American? Does this image fit an American prototype for Mexican American? I think most Americans would agree that it does. But why? Well, I think we can agree that the American cultural prototype of Mexican Americans includes someone whose skin is darker than that of an English, Scottish, Irish, German, or Italian American, which, for better or worse, tends to be our American cultural prototype of what an American looks like. So one of the ways that our American cultural prototype of Mexican Americans operates is we think of Mexican Americans as people having darker skin, at least when we compare them to people of other ethnicities who are also American. But we also think of Mexican Americans as having dark hair and dark eyes. Of course, most people in the world have dark hair and dark eyes. So our American cultural prototype of Mexican Americans might also remind us that many people of Mexican descent also have indigenous heritage. And so we might look for high cheekbones or rounder faces or broader noses, all as indicators of Mexican American heritage. Now, what about this image? What ethnic prototype does this image fit? Despite the fact that we as Americans do have prototypes for ethnicity, we also know that not all people of a given ethnicity necessarily align with the prototypical appearance. This woman, despite her pale skin, is also Mexican American. In fact, these two exemplars are pictures of my parents. Here you have a couple of images of myself and my family, one when I was a child and one not too long ago, just last year. We are all Mexican American, although of the four of us, only my father was born in Mexico. Here's a funny thing that happens when we categorize information. Once we place something, an object, an event, etc., into a category, we tend to remember that object, event, whatever, as closer to our prototype for that category than the object actually was. In other words, when encoding and retrieving information later, the prototyping gets stronger. We remember a dog we saw on our walk as more prototypically dog-like, however we may individually define that term, than the dog maybe actually was. Conversely, the more ambivalent we are about a thing, the further away we perceive it to be from our prototype, the more category boundaries blur. This happens all the time when we think about ethnicities. For instance, how would you categorize these people on screen? What cues about their image help you determine categorization? I'll bet many of you originally characterized this woman as having strong European descent, but she's also Mexican American. In fact, she's my cousin. She married a Pakistani American, and the little girl is one of their children, an American of Mexican and Pakistani descent. Here's the thing about our mental organization. Our propensity to remember and categorize information through prototypes basically means that our brains may be hardwired to stereotype. In cognitive psychology, a stereotype is an overgeneralized belief. It occurs when a person experiences one or two exposures to something, categorizes it in some way, and then generalizes that categorization to an entire population. For instance, let's say that a child gets scratched by their family's pet cat. Well, getting scratched hurt. The child places the cat into an "it hurts me" category and then overgeneralizes that experience with their family cat to all cats. the child makes an assumption that all cats will hurt them. In and of itself, a stereotype doesn't have a value. It isn't negative or positive, but it does influence behavior moving forward. In social psychology, stereotyping is associated with how one perceives a person and, by extension, a population. In this context, stereotyping is seen as negative. Even a quote-unquote positive stereotype can have negative consequences. For instance, a pervasive positive stereotype holds that all people of East Asian descent, and especially males, are naturally smarter than others. Why is this a problematic stereotype? It's problematic because it's false. It creates an expectation of inevitable academic success, and it ignores an individual's hard work. It takes into account only the final result, usually a grade, and often a grade in math or science, not the process of learning. The stereotype also establishes an inevitability of non-East Asians as being less smart. Moreover, this stereotype is associated with a patriarchal social structure which, over time, has generally ascribed better qualities to males, a stereotype which is also false. Academic giftedness is present in all ethnicities and genders. It is not the purview of just one group of people. One of the more important aspects of our cognition is the ability to apply concepts to problem solve. There are a multitude of ways in which we problem solve, and we apply a different method depending on the problem we're faced with. The problem set you worked on during your last class was meant to help illustrate these approaches. Let's review these approaches now, give them a name, and then explore how you use them in your problem sets. We sometimes use a trial and error method, especially when we're facing a problem we've never seen before or which has lots of variables in it. By alternating the variables that change, we eliminate paths that don't work. You may have used a trial and error approach to solve the hobbits and orcs problem. Maybe you also used it for the truth tellers and liars problem. Trial and error is a very early method that many of us adopt as children, figuring out what works and what doesn't, until we have enough experience with something that we know a method we might use to solve a problem. At other times, we'll use an algorithm, a step-by-step procedure that, provided it's done right, guarantees reaching the correct answer. Obviously, our system of using formulas in mathematics and science operates via algorithms. If you do the math correctly, then you get the correct answer. Many of you may have used an algorithmic type approach, creating a matrix to solve the husbands and wives problem. Now, even with the matrix, you may have resorted to a little trial and error to fully determine an answer. Once we become familiar with algorithms, we use them more regularly in our day-to-day lives. In most everyday situations, though, humans rely on heuristics, or a way of figuring out a problem that's based on something you've done before, so you've developed a sort of rule of thumb about it. For instance, let's say that you've noticed that your local H-E-B has signs in each aisle that tell you what's contained in that aisle. However, you're visiting Houston, and the nearest grocery store is a Kroger's, not an H-E-B. But you're armed with the knowledge that your grocery store has aisle markers, so when you walk into the Kroger's, you specifically look for aisle markers to help you find what you need to purchase. That's an example of using a heuristic. You may have used a heuristic to solve the hobbits and orcs problem, or the husbands and wives problem, or maybe all of them. Maybe you had approached a similar problem in the past and you remember that, and you tried to use the same approach when determining a solution to one of these 4 problems. There are, of course, obstacles to clear thinking and problem solving. Your text covers several. I want to reiterate just a few. The first is the problem of confirmation bias, our tendency to find and trust information that confirms our existing beliefs. The information we find may be technically factual, but because we don't look at all the information that's available, or we don't value all that information in the same way, we end up confirming, or rather thinking that we're confirming, what we already believe to be true. Confirmation bias is a problem because we then act on our beliefs, and we believe that these beliefs are true, even when they might not be. Humans also regularly experience fixation, the inability to see a problem from a fresh perspective. Part of our tendency toward fixation is that humans operate within a mental set, which predisposes how we think. Our tendency to use an approach that has worked for us in the past is our mental set. So we approach the same problem in the same way, and that doesn't work. Well, fixation generally means that even when multiple attempts are unsuccessful, we're unable to get around the corner and figure out another way to approach the problem. One aspect of fixation and mental set is called functional fixedness. This is our tendency to think of only the familiar functions for objects. We might say that this obstacle to clear problem solving blocks us from thinking outside of the box. For instance, take this object on screen. This is a paperclip. It was designed to hold loose papers together. That's how most of us use paperclips, but that's not all a paperclip can do. When we embrace divergent thinking, we can use the humble paperclip for lots of purposes. It can hold up our cell phone to an optimum viewing angle. It can replace our broken zipper or hold back our hair from our face. A paperclip can help us find the end of a roll of tape. We can even use many paperclips to make jewelry. Breaking out of our functional fixedness can allow us to see any number of objects in our environment in a new light. This helps us adapt to our environment that much better. As we've noted before, our brains are amazing. The field of cognitive psychology continues to provide knowledge and insights into the human condition, but the way we've evolved to use our brains to perceive and engage with the world around us is still not fully understood.